Hello, Space Captains! Welcome to the OREVEINS Education Advanced Kids Coding Classroom. Today, we are going to challenge Level 3, Lesson 8, Space Junk Collector. In our previous classes, we mastered basic clone controls and simple conditional statements. Today's lesson marks a massive leap forward in your computational thinking. Our core learning objectives include custom blocks with parameters. Learn how to build a custom code toolbox to condense repetitive detection logic, drastically optimizing your program's architecture. Concurrent multi-threading. Program a single clone to run multiple scripts simultaneously in the background, executing movement, special effects, and velocity changes without interference. This is a critical milestone on your journey toward independent game development and building advanced computational thinking. Let's blast off into today's cosmic adventure. Warning, warning, the spacecraft is entering a hazardous cosmic debris field. Look at our stage screen, Captains. In the vastness of deep space, an endless stream of space junk is drifting toward us. We can spot irregular metal blocks covered in reddish-brown rust, light brown asteroids riddled with deep craters, and completely abandoned, broken satellites coated in oxidized iron. To make things even more volatile, massive radioactive space junk will randomly spawn. They are colossal, flash with shifting neon colors, and due to their massive inertia, they cruise at twice the speed of normal debris. If we let these giant radioactive hazards collide with our spaceship, it will be an absolute disaster. As the supreme commander of this vessel, you must immediately activate the Space Junk Collector. Our ship is equipped with a state-of-the-art quantum energy beam collector that can emit 3 distinct wavelengths of recovery light using the J, K, and L keys on your keyboard. However, your quantum beam must perfectly match the material of the space junk to safely dematerialize and recover it. Press the J key, fires a beam targeted at metal. Press the K key, fires a beam targeted at rock. Press the L key, fires a beam targeted at satellite. To add to the ultimate challenge, you must initiate an accelerated response and clear out as many giant radioactive space hazards as possible before your 60-second fuel gauge hits zero. Commanders, the quantum engines are primed. Let's head into Scratch, prep our assets, and begin our galactic cleanup protocol. Before diving into the core scripts, we need to carefully set up our space stage and design our actors in Scratch. Please follow these structural guidelines precisely. Add background. Upload or select space background from the Scratch backdrop library. 2. Draw game over text. Click on the Backdrops tab, select the text tool, and type a large Time's Up, format, red, bold, to serve as our game over announcement icon. Core sprite, space junk. Delete the default Scratch cat. Create a new blank sprite and name it exactly Space Junk Messages. Inside its Costumes tab, add 3 cartoon-style space debris assets sequentially. You must manually rename these 3 costumes into pure lowercase English letters, exactly as follows. Costume 1 name, rename to Metal, the irregular metal block with reddish-brown rust. Costume 2 name, rename to Rock, the light brown asteroid with deep craters. Costume 3 name, rename to Satellite, the broken, rusty, abandoned satellite. Global variables. Create 2 new variables in the data category. Make sure they apply to all sprites. Score. Tracks the total number of space junk pieces successfully recovered by the player. Time. Serves as our 60-second countdown game clock. To keep our game running buttery smooth, we need to deconstruct our game logic into 2 foundational computational algorithms. Algorithm 1, dynamic data matching, custom block parameters. If we were to write 3 separate detection scripts for each of the 3 debris types, our code would become incredibly bloated. Instead, we introduce the concept of object-oriented functions. We create a pink custom container block named Recover Debris and equip it with a data pipeline or input variable called junkType. When a player presses the J key, we send the word string metal down the pipeline. Once the function receives this string, it immediately reads the current clone's costume name and cross-references it with the incoming data. If they are a perfect match, it means the player pressed the correct key, immediately triggering a score increase and deleting the clone. Algorithm 2, parallel multi-threading algorithm. The massive radioactive junk must execute three distinct behaviors at the exact same time: move right, flash neon colors, and sprint at double speed. If we cram all of these into a single loop, the wait time required for the flashing effect will completely stall the movement speed, causing the sprite to stutter, moving one step, pausing to flash, and moving another. To prevent this, we deploy a multi-thread decomposition algorithm. We use one single when I start as a clone block exclusively for base movement, and two additional independent when I start as a clone blocks to evaluate sprite scale. The moment size-45 is true, the other two background threads fire concurrently. One forces the color cycle shift, while the other piles extra velocity onto the x coordinate. 3 threads, 0 lag. Mission accomplished, Space Captains. Your planetary cleanup operations are complete. Huge congratulations on passing the advanced tests of multi-threading and parameterized custom block architectures to build your fully operational space junk collector master project. Learning to program is an incredible exploratory journey. If you run into any bugs when completing your homework, or if you take on our advanced challenge, adding a fourth space debris costume type linked to a fourth key command, and find your custom parameters returning an unexpected error or a 0, do not worry. Reach out immediately inside our student community workspace. The entire OREVEINS education team of passionate, supportive instructors is always online to guide you and provide step-by-step code debugging. If you love this science fiction-infused Scratch programming adventure today, please smash that like button, subscribe to our channel, and share this lesson with your friends who love technology, game design, and creative coding. Your incredible support is what inspires OREVEINS Education to keep pushing out top-tier computer science curriculum. Stay curious, keep coding, and we will see you in our next cosmic engineering voyage. Bye for now.